Scientists will give you is calculations and and theories why that happens, but we have experience. We see things and they either make sense or they don't make sense. What the scientists do is substitute our common sense and our intuition for calculations and theory, and we're supposed to believe the calculations rather than what we experience ourselves. There was a famous experiment back in the 1800s in England called the Bedford Levels experiment. Now, the Bedford Levels is a canal that is perfectly straight for 6 miles. Okay, so what a chap called Samuel Rowbotham did was he took a telescope, put it in the water about 8 inches above the water, and he had a friend, in a rowboat with a flag on the back, row all the way to the other end, and he was able to see the flag on the back of the rowboat the whole distance. Now, according to spherical trigonometry, the curve of the Earth is 8 inches per mile squared. So over 5 miles, that's 5 times 5, 25, times 8, which is 200, works out, that's 200 inches, which works out at 16 feet. That means the boat should have been 16 feet below the horizon. You shouldn't have been able to see the boat. Now, the scientists will say, oh, refraction and this and light bending around the Earth and stuff. But the fact is, it's perfectly flat. And he in his book, he puts forward many arguments that show that, or many experiments that show the Earth is always perfectly flat. They say that you see the mast, go down last. It's literally just the way your vision works. Yeah, it's perspective and atmospherics basically. The limit of your vision is supposedly 3 miles. And then after 3 miles, you're supposed to see the boat start to go over the horizon. It's funny that Neil deGrasse Tyson again says that, explains that you can't see the curvature of the Earth from a plane. He says this, you can't see the curvature of the Earth from a plane because you're not high enough. The Earth is so big that you can't get high enough to see the curvature. Yet, you can apparently see a boat go over the curvature over the distance of 3 miles, which doesn't make sense. The thing is, when you look out and you see a boat start to go over the horizon, if you suddenly get a pair of binoculars and look, it comes back again. And once it goes out the sight of your binoculars, if you get a telescope, it comes back again. It doesn't go over any curve of the horizon. What we found, many people have done experiments with very high-powered zoom cameras, and they've watched a boat sail out to sea, and they've just kept trained on this boat. And what they see is, after a very long distance, you see an atmospheric effect where the bottom of the boat disappears and and the top of the boat inverts, so you see a sort of mirror image. And that, with your eyesight, basically the bottom of the boat just melts into the horizon. One of the best examples of that is the Antwerp Notre Dame spire, which can be seen something like 240 kilometers away from the spire. So that should be over a mile below the horizon, and you can still see it. There's been a few famous examples just recently of a man who took a picture across the Great Lakes from Michigan and was able to see, I believe it's Chicago, which he shouldn't have been able to see. And the television station basically said it was a mirage.
This is from Joshua Nowicki, and what you're seeing here is a mirage. We typically would not be able to see this from the Lake Michigan shore. We talked about this last night. Conditions are right on the lake that we're actually seeing a mirage of the Chicago skyline.
They always say it's a mirage, but for a mirage to happen, you have to have very specific atmospheric conditions. And there have been so many people who have seen exactly the same thing on different days, different seasons, always the same. It's not a mirage. It's simply that you're looking across a plane. you see in a kind of pyramid shape. Yeah, you have a horizon at your eye level, and everything above the horizon will go down into the horizon. Yeah, everything below the horizon will seem to go up. Just like if you look you're in a long hallway, you'll see that the walls will start to move in, and the roof and the floor will start to move into the centre. Yeah, so literally between you and the object you're looking at, there's all sorts of things, sort of like waves going up and down, and while you can't see them, if they're beyond the limit of your sight, sometimes they can still obscure what you're looking at. But it's just because they're between you and it, and it's just the way. It's literally perspective. It's better if I could draw a diagram, but it's a very difficult subject to get your head around if you're not used to it. But it is perspective. One sort of other proof is there's a place in Bolivia called Salar de Uyuni, which is a salt flat. It's literally 100 miles wide one way and 80 miles across, and it's perfectly flat. When it rains, literally you get an inch of water, and it looks like a perfect mirror. Now, how does that happen on a sphere? Yeah, it shows you that, if you're one end of this salt flat, you can see perfectly clearly the other end 100 miles away. So it's just showing you that the Earth is flat, and without the effect of the waves in the sea, you'll be able to see a whole lot further.